Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, today we will take one more question number 16 of JEE 2014 Physics paper 1. So let us start with question number 16. Students, let us solve the next question. Question number 16 is about galvanometer, moving coil galvanometer. A galvanometer gives full scale deflection with 0.006 ampere. There is a galvanometer which gives full scale deflection of, that is, Ig value is given as 0.006 ampere. So this is the maximum current that this galvanometer can measure. By connecting it to a 4990 ohm resistance, so when this galvanometer is connected in series with 4990 ohm resistance, it can be converted into voltmeter. So this device will now become a voltmeter. This becomes a voltmeter, and it can measure up to 30 volt. So the range is now, range of this voltmeter 30 volt. If connected to a 2N/249 ohm resistance, it becomes an ammeter. So this galvanometer the same galvanometer, when connected to the resistance which is given as 2N/249 ohm, when this is connected to 2N/249 ohm resistance, it becomes ammeter and measures up to range of 1.5 ampere. So this becomes an ammeter which can measure up to 1.5 ampere. So we have to find the value of N. We have to find the value of this N. So first of all, you can see that we have to find the resistance of the galvanometer. In this expression, we know that to find the resistance of galvanometer, if the initial, you have to find the initial voltage, the maximum voltage that the galvanometer can measure when there is no resistance connected in series. So when you connect a resistance of 4990 ohm, it will become a voltmeter. But before that, the maximum range or the maximum potential difference the galvanometer can measure is obtained by Vg equals to Ig into G. So Vg is Ig into G. Ig is the maximum current that can flow through the galvanometer multiplied by the galvanometer resistance. So this was the earlier case. Now we have to convert this into a voltmeter of range. The maximum voltage that you can measure is 30 volt. So that means this is N times Vg. This N is different than the N asked in the question. This is another N, suppose N dash. And we know that to find the number of times the voltage become, we know that the resistance that is used is R equals to G into N dash minus 1. This is the value. And this R is given as 4990. The galvanometer that is to be used is not given, that you have to find. N dash is V upon Vg minus 1. Now V upon Vg, Vg is Ig into G, so we can write that V is 30 volt, the maximum that you can measure is 30 volt, divided by Vg is Ig into G. So Ig is 0.006, Ig is given as 0.006 into G, G is the galvanometer resistance minus 1. So from here you can get the value of G. Once we get the value of G, we substitute that in other equation. So let us solve this first. Solving this, we have 4990. This G goes inside, so it will become 30 divided by 0.006 minus G. Okay, so what you done is just you take this G into the bracket, so this G and G will cancel and the one G will be here. So now this minus G after this side becomes plus G, and this becomes 30 divided by 0.006 minus 4990. If I solve this, you will get 30 multiplied by 1000 divided by 6 minus 4990. This becomes 6 5s are 30, so this is 5000 minus 4990, so it becomes so it's 10 ohm. The galvanometer resistance is 10 ohm. So after you get the resistance of the galvanometer, then that we have to convert it to ammeter of range 1.5 ampere. So our aim is, you can see that our aim is to get ammeter of range 1.5 ampere by connecting 2n upon 249. To convert this galvanometer, which have resistance of 10 ohm, this is the galvanometer resistance. Now this galvanometer is connected in parallel. This process is called shunting. When you shunt a resistance of 2n over 249, then this becomes a ammeter, and it can measure up to maximum current of 1.5 ampere. This is given in the question. If this is the maximum current that can be measured afterwards, then what was the current it was measuring before? So before this resistance is connected, it was measuring a current of Ig. If I current is the maximum current that it can flow through the galvanometer without the galvanometer being burnt, then this Ig will flow as usual, which is 0.006 ampere will flow through the galvanometer. The remaining part of this will flow through the shunt. This is the shunt resistance. And what is the value of current that is passing through this? This is I minus Ig. So this will be 1.5 minus 0.006. This ampere will pass through this, and this is 0.006 ampere. Now you can take the potential difference here and here equal, because they are in parallel, and you can solve for n. Or we know that the shunt resistance required to have a number of times. Suppose in this case I will write n double dash. N double dash is I upon Ig. How many times the current is increased? So I upon Ig becomes 1.5 divided by 0.006. So this becomes 15 divided by 10, and this is 6 divided by 1000. So this goes now 1500 by 6, 3 2s are 6, 3 5s are 15, so 500 divided by 2, so it is 250. So this is 250. So this n double dash is 250. So the number of times the current has to be increased that can be measured is increased by 250 times. So we have the formula. The formula is S equals to G over N minus 1. Here N is the number of times it is to be increased, so here it is double dash. So if I use this formula, S is G over minus 1. S is given as 2N divided by 249. This G we got 10 ohm divided by, this is 250 minus 1, because N double dash we got as 250. So this is 2N divided by 249 equals to 10 divided by 249. This will cancel and then N becomes 5. N becomes 5. So that is the answer to this question. So the value of N is 5. This is the answer. But you can let me just derive an expression for you. So where you got this formula? So I will just derive the formula for you. So let us derive how you got this formula. Derivation of S is where you got this formula. When there is a galvanometer and a shunt is connected, the maximum current that can pass through is Ig. This is I minus Ig, and the maximum current that flows through is I. This is the final range maximum current that it can measure after this is connected. Before this is connected, this is the maximum current that the galvanometer can measure without shunt. So now because they are parallel, so we'll write that Ig into G, current into resistance, that is the potential drop across the galvanometer, must be equal to the potential drop across the shunt. So the potential difference is I minus Ig into S. So from here I write that Ig to G equals to, if I want S, then divided by I minus Ig, then this becomes S. From here S is G into Ig divided by I minus Ig. This you can solve as G into, this Ig is brought down to this dividing the expressions in the numerator and denominator by Ig. This becomes 1, this becomes I over Ig, and this becomes minus 1. We know that I equals to N times Ig, so N is I over Ig. So this is the number of times this is increased. So this is G into 1 over N minus 1. This is the number of times the current is increased, the range is increased when shunt is taken into account. So therefore G is this, and therefore G divided by N minus 1. This is the shunt that is used. So therefore we directly use the formula over here. S is G divided by N dash double dash minus 1. So this is how you can use the formula. Similarly, the first case, in the earlier case we used one more formula for the range. For the range of the voltmeter, for voltmeter we use the formula, the resistance that is connected in series is G into N minus 1, where N is the number of times the potential difference is increased. So this also can be obtained by using the formula. You have got a galvanometer and a resistance R, and the current that is flowing is Ig. Now the potential difference across this, final potential difference, and this is the potential difference across G. Now you can see that this potential difference is Ig into G plus Ig into R. So if I take from here, because the potential drop will be the sum of the individual potential difference across this, so V equals to, if I take Ig, I want R, so Ig into G plus Ig into R. If I want R, I could separate this. R equals to V minus Ig into G divided by Ig. This becomes V by Ig minus G, and V by Ig, it can be written as, what is V? V is the final potential difference which is in the range, and that is n times the initial Vg, and initial Vg is Ig into G. So therefore, if I substitute this value over here, in place of V I substitute this, so this will be n Igg divided by Ig minus G. This Ig will cancel out. From these two expressions I will take G common, and this will become n minus 1. So these two equations we directly used, and therefore using those two equations we will get the expression for final answer for the n, and we got this n to be 5. Okay, thank you.